Let's look at creating and interpreting linear equations. To do this, we're going to focus on how to create the algebraic equations and how to interpret equations that currently exist or that are already provided. So to create or interpret algebraic expressions or equations, in this case, we're going to identify the variable that does not change and the variable that changes, and we're going to use that to figure out how to create or interpret equations. Now let's start with an example here. It says Ryan intends to become a member of Total Fit Gym. He is told that a membership is a one-time fee of $125 and a monthly fee of $17. How much would he have paid after X months as a member of the gym? So, as we said earlier, we're going to look at variables that do not change. So, what does not change? The one thing to look at it is, what is it that will not change based on the number of months that he is a member of that gym? So we're told that there is a one-time fee of $125. So let's say constant is going to be $125, and then the variable is $17. But we're dealing with X months, so let's assume that the T is going to be the price that he would have paid. So we have a constant of $125 and we have $17 each month, so we have $17, and so after X months he would have paid 17 multiplied by X. So in this case, the cost of being a member of that gym, let's call it T, is going to be 17X plus 125. So this is $17 a month plus $125 fixed rate or one-time membership fee. Let's look at another one. A cab company charges a $4 boarding fee. That means every customer pays $4. Okay, so let's say a constant, and that's going to be $4. In addition to its meter, which is $1.25 for every mile. So this is variable because it changes. So this is $1.25. Create an equation that represents the cab company's rate. Let's call it R. We're going to look for the constant, which is 4, and then a variable of $1.25, and then for each mile, let's call that M. So for every mile the customer travels in this cab, you pay a $4 boarding fee and $1.25 per mile. So that means that the rate is going to change based on the number of miles that is traveled. So R equal to $1.25 per mile plus $4 boarding fee. A refrigeration company pays its salespersons a daily rate of $185. So this is constant. Doesn't matter how many sales the salesperson makes. We have $185 and a 5% commission for every unit sold. So we have a variable is a 5% commission. So 5%, which we can also write as 0.05. Tim, who's a salesman at the company, sells M units at the end of his first day. Create a function modeling this situation. Okay, so let's call it S for the number of sales. So we're going to say S is the amount of sales that he made. So S is going to be 185 is going to be a flat rate plus then 5% per unit sold. So this is going to be the variable and this is going to be your constant term. So I just like to rewrite it with the term handling the variable coming first. So this is 0.05 m plus 185. Now we're going to look at how to interpret already existing equations. So a building contractor's revenue between 2010 and 2016 is modeled by the equation above, where R is the amount of money the building contractor earned in millions of dollars and T is the year, assuming T is 0 in the year 2010. What do 1.3 and 18.9 represent? So let's look at what 18.9. 18.9 is a constant because it doesn't have T attached to it. 18.9 is the constant here. So now we need to understand what that constant means. And we have 1.3 is the variable. This consistently changes. Now we're told that in 2010, T is equal to 0. So let's look at that. So R is equal to 1.3 times 0 plus 18.9. So in 2010, the revenue is $18.9 million because we're told that the revenue is in millions of dollars. So R is 18.9 in 2010. So 18.9 is the revenue in 2010. Now, here T is the number of years after, so from 2010 to through 2016. So T represents the increase in revenue, is the rate of increase in revenue. So the rate of increase is equal to 1.3 because for every year that goes by, the revenue increases by $1.3 million. So that's what 1.3 represents. Rate of increase is 1.3 based on the number of years. So that's how you simplify this. Now let's look at a final example. So Leslie fills up her gas tank before going on a drive to visit her grandparents. The equation above models the amount of gas in her car when she has driven X miles. What do 24 and 17.5 mean in the equation? So we're told that L is 24 minus X over 17.5. Now, X is the number of miles. So let's look at this. If she hasn't driven at all, X is going to be 0. So when X equal to 0, L is 24. So this just tells us that 24 represents the amount of gas in her car before she begins her journey. So gas in car before journey begins. Alright, so that's what 24 means. Now, what does L represent? L represents the amount of gas in her car after a specific number of miles that have been driven. So here, let's look at X is miles over 17.5, and we already know that L represents the amount of gas in the car. So what can we deduce about 17.5? So initially we have 24 gallons in the car, After she drives a specific number of miles, we expect a reduction of the number of miles divided by 17.5. So what can we deduce that 17.5 represents? One way to look at that is to say that the number of miles divided by 75 represents the amount of gas that is used in that for that specific number of miles. So that simply means that we have 17.5 miles for each gallon. Now, how can we prove that? If we make the number of miles the same as 17.5, it means that the number of gallons will go down by 1. So every 17.5 miles, we lose a gallon of gas. That's really what 17.5 represents. So 17.5 is the number of miles per gallon, and 24 is the starting number of gas in Leslie's vehicle.